Live lesson, systems of equations, chapter 5 stuff. We're going to look at systems of equations using 3 different methods: graphing and substitution and elimination. So I have my 2-year-old daughter next to me, so prepare for distractions of all kinds as she tries to pull my cat off of the couch. All right. Problem 1. Solve by graphing. When you solve a system of equations by graphing, what you do is you graph each line, find out where those lines intersect, and that point where those 2 lines cross is going to be your answer. So that guy right there is already ready to be graphed because y is all by itself. So if I were to graph this one, I'd start at 3. And because 3 is the y-intercept. I would go up 5, left 3. Well, I can't. So I can go down 1, 2, 3, 4, 5, right 1, 2, 3. And can I do that again? Nope. So there's my first line. If you're not sure about graphing, I have tons of videos about graphing. Just search Nick Perich, graphing linear equations. Like, subscribe, and send me that sweet, sweet, sweet YouTube money. I'm going to graph the bottom one in green. I'm going to start at -3, so put a dot at -3 on the y-axis. My slope is 1/3, so I'm going to go up 1, right 3 because it's positive. Boom! Up 1, right 3. Well, I ran out of space. Down 1, left 3, so I'm going back to my original space, going down 1, left 3. Those are as many dots as I can put. I'm going to draw a straight line. Boom! There's my intersection. Okay, so I'm going to mark it blue. And you have to write out the point where those 2 lines intersect. And the point where those 2 lines intersect is 3, -2, which means 3, -2 is my answer. If you solve by graphing, you graph each line, find out where the lines cross, where they intersect, and the point where those lines intersect is going to be your answer, your solution, if you will. Let's take a look at another one. Similar problem. I'm going to graph u in green. It's already able to be graphed because it's in slope-intercept form, y equals mx plus b. I start out by putting a dot at 3 because that's my y-intercept. You put a dot at that 3 right there. My slope is 4, but I hate the way that looks, so I'm going to call it 4/1 because any number... Remember, slope is rise over run. And you can turn any number into a fraction by putting it over 1. Up 4, right 1. Well, I can't do that, so I can go down 4, left 1. Down 4, left 1. And those are the dots that I can make. Positive slopes go up and to the right. And in the case of the next one, I'm going to have a negative slope, which is going to go down and to the right, or up and to the left. So I'm going to start at -2. Boop. Because of this y-intercept. My slope is negative, or -1, or -1/1, which means I go down 1, right 1, put a dot, down 1, right 1, put a dot, down 1, right 1, put a dot. Uh-oh, ran out of room, go to the original dot, up 1, left 1, put a dot. Ooh, up 1, left 1, put a dot, up 1, left 1, up 1, left 1, up 1, left 1, blah, blah, blah. What? Why are you yelling? Those children. Don't have kids until you're ready. Put a dot right there. The dot where those 2 lines intersect is going to be -1. -1. Okay? All right. So we're going to move on from graphing and do substitution. Substitution is a step-by-step process. Again, if you're not sure of this method, I have like 3 or 4 or 5 videos online where I use this method, and I really explain it out pretty well. So like and subscribe. Substitution says my first step is to take any equation and solve it for any variable. The top equation is already solved for y. Y is -3x plus 5. So what I can do is, since y is -3x plus 5, I can turn that y right there into -3x plus 5. I'm turning y into negative 3x plus 5. So I'm rewriting the bottom equation, 5x minus 4. And instead of y is negative 3x plus 5. I'm turning y into negative 3x plus 5. I'm substituting. And now I'm going to finish writing out the bottom equation. So all I did was, since the top equation was solved for y, I rewrote the other equation and turned y into negative 3x plus 5 because y is negative 3x plus 5. Now I have a lot of terrible math to do. I have distributed property right here. So I have 5x, nothing changes there. Negative 4 times negative 3x is positive 12x. Negative 4 times positive 5 rather is negative 20. And that's going to equal negative 3. On the left side, I have a 5x literally living right next to a 12x. So if I have 5x's living next to 12x's, I'm going to have 17x's, which sounds like my dating history because of my exes. Am I right, kids? I'm not right. No one's even watching me anyway. If I'm going to solve for x, I have to get x all by itself. So is x all by itself? No. What's in the way? Well, two things are in the way. I have 17 multiplied to x, but I also am subtracting 20. And I have to do the opposite of subtract 20 by add 20. And that's what I'm going to do right there. Let me write it up here. 17x equals 17. What are you watching? Yeah, stop. My gosh, children. Don't have children until you're ready. Is x all by itself? No. What's in the way? 17. How is 17 in the way? Multiplied. How do I get rid of it? Divide. Divide both sides by 17. Divide both sides by 17. Cross you out. And x equals numero uno. Now, I have x. As we could see from the last problems, it wasn't good enough just to have an x value. No, we needed an x and a y. So going back, I need to find my y. How can I find my y? Well, y equals, according to the top equation there, y equals negative 3x plus 5. I now know what x is. So I'm going to write out y equals negative 3. And instead of x is 1 because I just solved for that, plus 5. Y equals negative 3 plus 5 because I multiplied negative 3 times 1. Negative 3 plus 5 is 2. So since x is 1 and y is 2, my answer is going to be the point where x is 1 and y is 2. Never said it would be easy. I only said it would be fun. And fun it is. Beep. Substitution again. In order to solve by substitution, I have to take one of the equations and solve it for one of the variables. Oh, look, the bottom equation is already solved for y. Y happens to be x minus 1. So if y is x minus 1 on the bottom, why don't I change the y on the bottom, or the y on the top, to x minus 1? Y is x minus 1. Y is x minus 1. So I'm going to write out the top. 2x minus 3. Y? No. Y is x minus 1. And I'm going to finish writing out the top. Just like the last problem, we have distributed property. Negative 3 times x is negative 3x. So I'm going to drop down the 2x, drop down the negative 3x, because negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. And that's going to equal negative 1. Just like in the last one, I have two x's living right next to each other. 2x take away 3x is going to be negative 1x or negative x, but I'm going to write out negative 1x. So I have negative 1x plus 3 equals negative 1. Is x all by itself? No. What's in the way? Well, 3 is in the way, so why don't I subtract 3? So when I rewrite that out, I now have negative 1x equals negative 4. Is x all by itself? No. What's in the way? Negative 1. How do I get rid of negative 1? Divide negative 1, divide negative 1. And negative 4 divided by negative 1 is positive 4. Cool, I have X, but I don't have Y. Well, that's not a big deal. Let me clean this mess up that I have over here. If Y is X minus 1, why don't I just write out Y is X minus 1? But instead of X, I now know that X is 4. So instead of saying Y is X minus 1, Y is 4 minus 1. 4 minus 1 is 3. And if my X value is 4 and my Y value is 3, then my final answer is going to be the 0.43. Okay. Okay. Elimination. That's what SpongeBob would say. SpongeBob SquarePants. All right. Elimination says that if you have two equations and they're all lined up, in other words, the x's and the x's are lined up, the y's and the y's are lined up, and the numbers and the equal signs and everything's all lined up, you're in really good shape. Also, if one of your letters is positive and one of your letters is negative and they happen to be the same number, you're in really good shape. So this is what I'm going to do. I'm going to add each of these lines here. So if I say negative 6x plus 6x, well, that just disappears. Look at that, easy. 5y's plus 4y's is 9y's. Okay. Equal and equal is equal. 1 plus negative 10 is negative 9. And then from here on out, it's easy peasy lemon squeezy. Is y all by itself? No. What's in the way? 9. What do? Divide 9. Cross you out. Negative 9 divided by 9 is negative 1. So now I have y is negative 1. I'm going to clean this area up because it's such a mess. I have y, but I don't have x. So in this substitution problems, once I found one of my letters, I plugged it into the equation, any equation, to find out my other letter. Usually I had a nice equation that I can plug it into. In this case, I really don't. So I have to find x. So I don't know. I have the bottom equation doesn't have as well. It's just they're both terrible equations. I'm just going to plug it into the bottom equation. I now know that y is negative 1. So I'm going to rewrite out the bottom equation, but instead of y, I'm going to write out negative 1 because y is negative 1. 4 times negative 1 here is negative 4. Is x all by itself? No. What's in the way? 6 is in the way, but negative 4 is in the way. So let's add 4, cross u out. 6x is going to equal negative 6. Is x all by itself? No. What's in the way? Times 6 is in the way. So let's multiply, divide, just kidding, both sides by 6. And x equals negative 6 divided by 6 and negative 1. X is negative 1. Y is negative 1. Negative 1 is my answer. Right? Just watching Coco Melon. Or Mother Goose Club, or one of those weird things. Oh, all right. Oh, look, everything's lined up again. Those two y's are the same. Oh, but no. I want one of those y's to be negative. So this is what I'm going to do. In order to turn that y into negative, I'm going to multiply the entire top by negative 1. Why? Because then I'll have a 2y on the bottom and a negative 2y on top, and they'll eliminate. That's the point, elimination. So if I multiply the top by negative 1, positive 7x becomes negative 7x. Positive 2y becomes negative 2y. Positive 24 becomes negative 24. If I rewrite out the bottom equation, 8x stays 8x, 2y stays 2x, and 30 stays 30. Now I have two equations that are perfectly lined up. The y's are the exact same number, but one of them is positive and one of them is negative, so I can add the columns up. Negative 7x plus 8x is x. How convenient. Negative 2y and 2y cancel out. Equal signs drop down. Negative 24 and 30 makes 6. So I now just found out that x is 6. I have x, but I don't have my y. So let me erase the original problem and make it look a little bit cleaner. I'll rewrite out the top equation, but instead of x, I'll plug in 6. Again, once I have one of my variables, I can plug it into any one of those equations and just substitute 6 for x. So I'm just typing it into the top one, or writing it into the top one. I'm not typing anything. So I have 7 times 6, because x is 6, plus 2y equals 24. I'm rewriting the top equation. 7 times 6 is 42. 42 plus 2y equals 24. Is y all by itself? No, 42 is floating around. Let's get rid of 42. Minus 42. 2y equals, what is that, negative 18? No, 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 no. What was that, minus 42? It is negative 18. What's wrong with me? Yes, 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 yes. Divide both sides by 2. Divide both sides by 2. Y equals negative 9. So if y is negative 9 and x is 6, then my final answer is going to be the point 6, negative 9. All right? So we did 2 graphing. We did 2 substitution. We did 2 eliminations. Let's do an any method. Wow, this is awful. Okay, no big deal. Let's take the top equation and solve it for x. Okay, I'm going to do substitution. I don't want to do elimination because it just looks bad. I'm going to do substitution. I'm going to take the top equation and solve it for x because I can. So I'm going to write out 2x plus 8y equals 6. Is x all by itself? No. What's in the way? Well, negative 8y is floating around. So let's subtract both sides by negative 8y, cross you out. I have 2x equals 6 minus 8y. Is x all by itself? No. What's in the way? To divide everything by 2. And the top equation is now x equals 3 minus 4y. So the top equation is now x equals 3 minus 4y. So what I'm going to do is write out the bottom equation, but instead of x, write out 3 minus 4y. So negative 5 times 3 minus 4y minus 20y equals negative 15. Distributed property. Negative 5 times 3 is negative 15. Negative 5 times negative 4y is positive 20y. Minus 20y equals negative 15. Oh no. Look, a 20y is right next to a negative 20y, which means they cancel each other out. Because if you have 20y's and you take away 20y's, they're all gone. Negative 15 equals negative 15. So if your variables disappear and you're left with 2 numbers that are equal to each other, what you have here is infinite solutions. It's been a while since we've done one of those. If your variables disappear and you're left with negative 15 equals negative 15, or 2 equals 2, or 8 equals 8, or a number equals itself, it's infinite solutions. If your variables disappear and you're left with something like 2 equals 3, which isn't true, or a negative 5 equals 12, which is false, that's a no solution. In this case, we have an infinite solutions because they're the same line. One more, and it's everybody's favorite, a word problem. The admission fee at a small fair is $1.50 for children. So X will be children and $4 for adults. On a certain day, 2,200 people entered the fair. All right, so all the kids and all the adults are going to be 2,200 people. I can handle that. Also, children are $1.50 and adults are $4. And that day they made $5,050. All right. All right. That's my system. How many children and how many adults attended? All right. So what I'm going to do is I did substitution on the last one. Let's do elimination on this one. What I'm going to do is I'm going to multiply the entire top by -4. Why am I doing that? Because if I can turn the y up here into -4y, then it'll cancel out that 4y down there. So I'm going to rewrite everything on the left here. -4 times x on the top is -4x. -4 times y on the top is -4y. -4 times 2,200 on the top is -8,800 on the top. And I'm going to just rewrite the bottom. 1.5x plus 4y equals 5050. 50 are the cops here? Now I can use elimination. Add those columns. -4 plus 1.5 is -2.5x. Those cancel out. And I believe this is going to give me -3,750. Is x all by itself? No. What's in the way? -2.5. So I'm going to divide everything by -2.5. I'm going to recruit Siri to help me out for this one. -3,750 divided by -2.5.
The answer is 1,500.
Look at that. So if x is 1,500, I need to find y. How can I find y? Well, look at this top equation right here. I'm going to rewrite the top equation, okay? And instead of x, I'm going to put 1,500. 1,500 plus y equals 2,200. Subtract 1,500 from both sides. Subtract 1,500 from both sides. And y is going to equal 700. So am I going to write this out as a point? 1,500, 700? No, because this is a word problem, and it's asking how many children and how many adults attended. X is children. So if x was 1,500, then we can say 1,500 children attended. And y is adults. Y was 700. So we could say 700 adults. All right, baby. And that's the end of that. Okay, live lesson on systems of equations. We covered 7 problems in about 20 minutes. I'm happy with our work. Are you happy with our work? You should be. I am. Very happy. Very happy.